lining. We got the Alamo Paint and Decorating. This one's just down the road from my house. That's it. Oh yeah, that's right. You also have the Alamo. All right, let's go to our actual presentation here, which is on credential assessment. And so I'm Matt Weeks. I'm Script Junkie. I'm not Script Junkie 1. Microsoft stole the Twitter handle Script Junkie right before I registered it. And then they later gave it up, but I still couldn't get it back. So I'm Script Junkie 1 on Twitter, which is what you see in your handouts. Just a little bit about motivation behind this talk. So when I start out, I say the first things that I did in security, I'd done more in the software development side of things. And then in college, I started to get interested in security, learned all I could, started to look for vulnerabilities and find exploits for zero-day vulnerabilities, sold a few of those. That was kind of a pain in the neck, so I didn't continue in that direction, although I have done a few since then. I did in addition to a CS major, I did a math major. I did some cryptanalytic research for my senior project. I broke Chinese code. Then when I went into actually getting a job after graduating, I first did a lot of work in the forensics and reverse engineering world. So did a lot of pulling apart binaries, looking through logs and master file tables and all that kind of thing. I then moved into a similar area into enterprise hunt operations, so looking at finding malware across a big network, finding out how people were moving through the network, getting in the network, getting into adversary C2 channels and doing lots of interesting things with that. And then red teaming, which I've done a little bit as part of that, also a lot with, for example, the CCDC and some other places as well. On the side, I've done some defensive development, which is my current job now, which is writing software for doing hunt things and identifying weaknesses in networks. I wrote the ambush hips to do that. All which is not to say, go look at me, I've been all here. There are certainly people, if you look at things like exploit development, people who have spent a whole lot more time than I have in that world and are better at that than I am. But having a glimpse of a lot of normally very separate fields, you start to see a lot of disconnects in between that. And so I'm going to be talking about one of those here, but a lot of times we see this, and it frequently happens due to kind of a pigeonholed focus in one area or one thing that you see. And to some extent, you'll hear a lot of red teamers say, you defensive guys don't know anything. You really need to do offensive to see the picture. And to some extent, that's true, but you also need to see the defensive side. Otherwise, you end up with some very not the best suggestions for fixing the problems that you find. And sometimes you find attention on certain things due to financial bias. You just have to look at your typical vendor area and vendor advertisements. Not so much at DerbyCon, but a lot of the vendors like to advertise. You just slap this box on your network and it'll fix everything. And obviously they have a financial incentive to do that. Other times you find a lot of attention in the research world and then to some extent conference world on the new and exciting new bright shiny objects versus the old and normal things that you need to do to take care of your network. So let's go on here. So one of the big things which has been attracting a lot of attention recently is some of the major breaches. And so what I'm calling the major breaches are the high impact breaches that result from complete network compromise. So everybody's seen, DDoS attacks or defacements. Those are annoying and matter, but they aren't the big major breaches which are really having a significant economic effect and significant effect on, just on a lot of different people. And so you can look at the effect from just data stolen. And so everybody's heard of the Target breach, the Home Depot breach, which was very similar, stealing credit card data, the JP Morgan Chase breach, which was again more financial data. We've also seen recently, certainly more so than in previous years, I'd say in the past about 5 years, we've seen destructive major breaches. And so the Sony breach is probably the most well-known of those, but it's certainly not the only one. The Sands Casino, or actually Las Vegas Sands Entertainment, not just the Sands Casino itself, but the entire business was hit. And that was Saudi Aramco a few years ago. And that was a major oil producer in Saudi Arabia. And so when we look at some of these, you know, Saudi Aramco had 30,000 systems which got wiped, and you know, enormous impact on their systems. These are normally accompanied by, you know, screens showing, you know, taunting messages toward the users and blasting music, or what was it, Thunderstruck or something like that. And so that ends up being very painful to a company, as all of a sudden tens of thousands of their employees can't get their work done, and there often is a lot of data which is lost, which is not easy to get back. So what is happening? What is causing these? So as a security industry, it's our job to fix that. Probably the best analysis which has been made public is done on the Target breach. And I pulled this diagram from the link there, which you can see. It started by infecting a vendor with a social engineering email, most likely. After having access to that HVAC vendor in Pennsylvania, those vendors' credentials were stolen by the bad guys to access a web server of targets which that vendor had access to. After that point, they were able to use those credentials and that access to exploit that web server, get a shell on that web server. They identified what was on that. They modified their malware to avoid antivirus detection, as Egypt was mentioning in the last talk, if you were there for that. And then they used the malware to steal credentials. They used something called Mimikatz to dump passwords and other credentials on that web server. Once they had those, they then spread their actual endgame malware, it was called Black POS, onto each of the point of sale, that's what POS stands for, systems. And those are the systems that were, you're swiping your credit card into, collecting your credit card data, and sending that all back to them, at which point they then sold that on the black market and made a lot of money. So what was the critical flaw in this? So they broke it down into, I think it was 11 different steps, which I've summarized a little bit. There was a lot of press coverage on this. A lot of it from Brian Krebs, who was the one who was leading a lot of the reporting on this. So the first thing he did was pointed out that Home Depot was hit by the same malware as Target. So here we're kind of focusing on this. This Black POS malware was something which, although it had been modified slightly, was something which had been seen before. Maybe if they had better malware detection, they would have been able to find this. Bloomberg has it right there in the headline. It says, missed alarms and 40 million stolen credit card numbers. How Target blew it. Well, how did they blew it? Well, real simple. They missed alarms. They had FireEye systems on the network, which sent off a couple alerts as these executables were being downloaded in plain text to their systems. And Target didn't respond to that. And that sounds very easy to. Well, of course that must have been it to a reporter, somebody outside the industry. If you've sat within a security operations center and you've seen the millions and millions of false positive alerts, this is not surprising at all, and certainly isn't a red flag to this is the biggest issue. Other articles talked about how even if you have a bottomless budget for security software, hardware, and services, it means little if you don't have empowered geeks to help recognize a breach early on. So it was their personnel that they should have been putting the money into instead of the boxes on the network. And that's certainly something which is at the root of a lot of issues. The US Senate even held a hearing and had a committee prepare a report on what happened here, which is rare for breaches, but they came up with 4 major findings. First one was giving access to the HVAC vendor who didn't follow great security policies. So it was this HVAC vendor compromise, this initial step here. The second one that they mentioned was the warnings, as was the 4th one that they mentioned. And the 3rd one, they showed that they had moved from one area of Target's network to another area, and Target probably should have isolated that. So maybe we should have added some network segmentation here to put a barrier in between these different servers. Other research or other articles again talked about breaking in via the HVAC company, that initial step there, and others. So to summarize, we had the missing alerts. According to Krebs, we talked about missing skilled incident responders. This initial access with the HVAC vendors. He also mentioned, well, what if they had just adopted end-to-end encryption? So he didn't go into detail here, but this is basically what the chip is. If you've gotten a new credit card and you've gotten a chip, you put that chip into Target, and those point-of-sale devices never have your credit card number. It does basically a cryptographic handshake with the bank's servers and should never release your credit card number. So if you do that, that's certainly one way to fix this issue. But that's not applicable generally, because a lot of companies are going to have sensitive information which they're going to need to protect, and you can't just say, I'm not going to keep sensitive information on my network. Obviously, minimize it if you can. So according to Senate investigations, again, you have your missed alerts, your HVAC vendor access, and on-off isolation. A similar story happened with the Sands Casino. This one I just love. The article about this is just amazing. I just want to read a piece from it. When this attack happened, the computers were flatlining, email was down, most of the phones didn't work, and several of the technology systems that helped run the $14 billion operation had sputtered to a halt. Computer engineers at Las Vegas Sands Corporation raced to figure out what was happening. Within an hour, they had a diagnosis. Sands was under a withering cyber attack. PCs and servers were shutting down in a cascading IT catastrophe, with many of their hard drives wiped clean. The company's technical staff had never seen anything like it. In an effort to save as many machines as they could, IT staffers scrambled across the casino floors of the Sands Vegas properties, the Venetian and the Palazzo, ripping network cords out of every functioning computer they could find, including PCs used by pit bosses to track gamblers and kiosks where slot players cash in their tickets. So in the middle of Vegas, they're running down the hallways, yanking the cords out of the walls to stop the cyber attack, and it wasn't even DEF-CON, for which I'm very disappointed in the hacker community. But yeah, it was an attack which hit so many of their servers across the world, so many of their casinos, and ended up shutting down a lot of their operations, costing them an awful lot of money. They go into describing how this happened. So the attackers had attempted to gain access in a few ways, failed, came back. They found a web development server, which was something that the Sands Corporation developers had stood up, but they hadn't locked it down. It was just a test server. It wasn't one of their production servers. They found a vulnerability in that, compromised that system. They used Mimikatz to steal passwords. They were then able to move from that server to other servers on that same network, that Bethlehem IT system. And on one of those other ones, using probably local administrator credentials, and then on one of those, they were able to find a domain or enterprise admin equivalent credential, and that guy's password or token or ticket, and then move from there to take over the entire Active Directory forest that Las Vegas Sands was using. And at that point, they controlled the entire network. So again, initially exploit via web server, stole passwords, repeated that until they found domain admin, and then they deployed their attack across the entire network. In this case, as far as I know, there were no alerts that were missed. Their initial attack did flag some alerts, but then their second one did not. And then we have Sony and Saudi Aramco, which is a very similar story. We don't know all the details for these attacks. However, we do know how that the end malware was spread across their network, and that was again via stolen admin credentials, causing a lot of chaos. So if we diagram one of these breaches, what we have is something that looks like this in every case. And so you ask yourself, well, let's plot how the industry is responding to these breaches. And so you've got number one, identify that initial access. Make it so they can't get into our network at all. So there's a lot of effort here. You have your vulnerability scanners. You have various pen tests often focus on this. You have various types of firewalls, web app firewalls, and I would say possibly most of the computer security industry is meant at trying to stop that first box or two from being compromised. And then you have an enormous effort over here on the right side of the graph to go after that malware. And so things like identifying that black POS malware, whether that's antivirus signatures or threat intelligence, which is just a fancy name for antivirus signatures you have to pay for normally. It can include other things like IP addresses and techniques as well, but a lot of emphasis on how are they doing that malware, how are they doing these techniques. And both of these are really critical parts of your information security program, but if you notice, something kind of happened in the middle there, and it seems to be pretty important. So what happened right over here? What happened here was the bad guys were able to steal a domain administrator token because those credentials were left on a web server. And in all these major breaches, what we find repeatedly is that credential theft grants you at least 5,000 times the access that your exploit or your social engineering attack did. Sometimes it's 10,000 or 30,000 times as much access. But it's really credential theft that turns that one system into 1,000 more. And what you find is, in my opinion, malware detection and software vulnerabilities aren't the biggest problem in enterprises. Leaving your admin creds lying around all over the domain tends to be that problem. So who's recognizing this problem? Well, you can just Google this target breach. You look for that HVAC vendor credentials, that initial access, and you get almost 500,000 results. You look for malware, and you get, again, almost 500,000 results. The first page in both of these instances, it's all mentioned right there in the title, right there in the headline. If you look for domain admin, you get very few results, about 1/10 as many, and none of them are in the headline. They're all in paragraph 11, step 5. There's basically very little focus on this comparatively. And that's not just in this particular breach, that's in the IT industry as a whole. And I think one of the biggest illustrations of this is, you look at for more than 10 years now, close to 15 years, Windows has stored complete passwords in memory, slightly obfuscated. It was implied by documented features, documented at least as far back as 2003. As far as I can tell, and I've asked a lot of people, this was not exploited offensively, certainly not publicly, until early 2012, over 10 years later, when Benjamin Delpy, who's not a dedicated security researcher, was making a hobby project called Mimikatz, which he was using to learn to program C and learn about Windows authentication. And if you look at just the breaches, so a few of them we've mentioned, but a lot of other ones, just the documented impact of Mimikatz in breaches surpasses that of virtually any exploit. You could say maybe there's a couple which passed it, but the documented impact of Mimikatz probably surpasses just about any exploit that we've seen in the past 5 years. So again, credential attacks tend to lead in real-world impact, but they still receive very little research attention compared to vulnerabilities. So why is that? And I don't have a great answer for that. I think there's kind of an attitude of, first of all, few visible alternatives, and I would say boring alternatives. People like that say, oh, well, I guess, or place the blame on the users and the administrators. They say, well, I guess you shouldn't have had a weak password. I guess you shouldn't have reused your password. I guess you shouldn't have logged into that system, or maybe you should just reboot, or, we just kind of go back to, oh, well, they had authenticated access. What are you going to do about it? And there's not a whole lot of, I think, imaginative solutions, and some of the solutions that are out there tend to be large software project deployments, which can certainly help, but tend to be a large IT issue. So how do we defend against this? So what I'm going to describe is kind of how we approach this from Route 9B's perspective as a security assessment in one of our security assessment services, I guess. First thing we want to do is identify the dissemination of credentials. So where are your credentials? Where are they stored? Where can we find them? Where are they in memory? Where are they on disk? And then once you've found that and who they all correspond to, identify which ones are reused. So who all is sharing credentials. And then once you've identified that, you need to identify both the direct and the indirect impact of the credentials. So what can those credentials get to, and figure out how to chain those together to get maximum impact. So you're not looking at just the impact of the one, but you're also looking at the impact of everything that you can get to from there. And then determine the mechanisms to break those chains, and say, well, where can we cut this off so it doesn't end up causing a cascading failure, and then go to clean it up. Hopefully identify if there's any changes that you can make to help prevent some of this stuff from happening in the future, and of course continuing to audit so that you don't just try to clean stuff up and then leave and then watch it all go back. So here's kind of our hand-wavy diagram of, we've got scanners, which will go ahead and collect all this information. They push out the collectors, that data gets pulled back into a big database, and then we do queries on that and kind of have our own homegrown UI analysis for that. So first of all, to scan all the systems, you do need to use credentials to do this. We don't have any fancy 0 days that we're using to spread this. It is a small collector. You can debate till the end of time about whether you want an agent or whether you just want to rely on existing logs or whether you want to throw out your own code. We did the throw out our own code method so that we're not leaving more stuff on the network, and it kind of fits more the assessment methodology. We then look at the credentials present, and this is something which was certainly more involved than I realized it would be. When you start getting into the guts of how this works, you find that Microsoft tends to lie a lot in its documentation. And so Microsoft has all these explanations of things. So for example, tokens, which is normally your biggest way of stealing your domain credentials from a single system. They come in 2 flavors if you read the Microsoft documentation. There are impersonation tokens and there are delegation tokens. And impersonation tokens, you don't really care. Because impersonation tokens just means, let's say a process is running as if it was, let's say, a privileged account on this system, but it doesn't really have that privileged account's credentials to then use against a different system. Delegation tokens are the other kind. Delegation tokens are the all-powerful kind. Delegation tokens mean not only am I operating as privileged admin on this system, but I also have privileged admin's credentials, and I can throw them at any system that I want and take over those systems. I can then steal and reuse those credentials. Again, all according to Microsoft documentation. And Interpreter actually has which was then based on the previous incognito, which will show you what tokens you have on a system. Unfortunately, though, quite a few of those delegation tokens actually aren't delegation tokens. When you ask Windows, is this a delegation token, it'll say, yeah, and it's not really. Or it'll say, no, it's an impersonation token, but there's really a hash or a Kerberos TGT in memory or something like that. And so we found we then had to do more stuff, more kind of like Mimikatz, to basically I'd check and see, is this hash really in memory, or is this Kerberos TGT really in memory? And so yeah, you have to do that, and then you also want to look in detail at what are all the user accounts on the system, what are all the relevant privilege assignments, so which groups have been granted which privileges on the system, what configuration details does that system have, because that ends up having a lot of effect on this ability to pass credentials, and identify all the security group memberships of all the accounts on that system and all the groups on that system. And once you've done that, you can then basically attempt to recreate that Windows authentication on the other side and identify how that has happened. So then we move on to extracting hashes. And so normally as we mentioned, Egypt mentioned in the previous slide, extracting domain hashes has often been a difficult process, which involves extracting the system hive and the ntds.dit file, which is huge. And then you have to extract the hashes from that, which is its own long process, which involves installing a whole bunch of dependencies, and it's really complicated, and there's a bunch of Python scripts out there which don't work, or they work on some like 2K3 version, but not the 2K12 version. But there's this handy website, extract.ntdsd.it, which you can just upload your domain hashes, and it'll just extract them all for you and give them to you. And what could go wrong? As far as I know, it still works. Works, I mean. But what we want to do was not that. Certainly, as they were talking about before, this was something that Mesplit has also now added on some handling for And that is you ideally don't want to have to extract this massive file out and then go run very intensive operations on it. So our method actually just parses the raw disk sectors and then parses the MFT and then reads it off the raw disk, which is kind of like doing a volume shadow copy, except not doing volume shadow copy. And so then we extract it from there. And then we just query the SAM ones from the registry. And so once we have that, the other thing that we do then is we don't want to contribute to this problem of grabbing a whole bunch of credentials. So we have a little bit different goals than Meterpreter does. So rather than store the original hashes in there, what we'll actually do is we will then hash them again with SHA-256 so that if you capture our hashes, you won't be able to replay them and pass the hash somewhere else. You'd have to crack them. So we use double hashes, which still allows us to check for reused hashes because the second hash will still be the same if somebody's reused their password, but reduces the danger of grabbing a whole bunch of credentials yourself. All right, so let's say we've done this on a couple of systems. We've got Workstation Alice, we've got Workstation Bob. They both have a guest account with a blank password. That's not going to be useful for anything. Alice has Alice's account. It's got one hash. Bob has Bob's account. It's got a different hash. No problem there. Except, oh wait, they've both got a local administrator account, and it's got the same hash. And so at this point, you might be thinking, uh-oh, somebody could compromise one of these workstations, pass that hash over to the other one. So in reality, again, there would be, just imagine like a funny Facebook video if the DerbyCon network was working, but it wasn't. And that fails. So you might ask yourself, well, okay, well, why did this fail? You know, administrators in the administrators group. Most of the time, this one actually does succeed, but it might fail. And so what we found is that, so what we're doing is we're basically taking account, tracing its rights through any groups that it's a membership of, and where those rights are assigned. And so you can see the local administrators group has been granted, well, it's not in the screen, but the local administrator group by default is granted SE network logon right, and a bunch of other rights like SE take ownership right, and others which equate to admin control. And so members of the administrators group generally do work for PSExec or however you want to take over that remote system, except if there's this setting introduced in Vista, which is the UAC run all administrators in admin approval mode setting, which is on by default, which blocks all the administrators from remotely, all the local administrators from remotely taking over that system with network logon. Except if it's the -500 local administrator account, which is the built-in administrator account, the one usually named administrator, unless it's French and then it's like administrateur or something like that. But the SID still ends in 500, so we just call it the built-in administrator account. But that will still work, even in Vista and later. Except when it doesn't work. And it doesn't work when that setting, UAC setting is, a different setting is set to admin approval mode for the built-in administrator account. And this is important because you can run into environments where hopefully they have this one set. And if this one is set, then the local admin accounts can't be used to go PSExec over to another local admin box, even if they have the same password. And we need to be able to identify that correctly. And one of the issues that you have is when you start talking about stuff like this, deep Windows authentication, you'll find a lot of people say, oh, well, the built-in administrator account still works for pass the hash, and then just stop there. And what we find is, actually, there's so many settings. Normally you can't just say this works or this doesn't work. You actually have to check all the non-default settings and all the non-default registry keys to see how is it really configured, because something which normally isn't an issue might be an issue, or something which normally is an issue might not. All right, so we try again, flip that back to the default, and try to go execute that, and it fails again. So wait, now what might be the issue? Not blocked by firewall, trying to authenticate. Does anybody know what could still block it? No, network logon rights are still granted, but that is something that could grant it. Well, logon times is something that could be an issue. In this case, what I did was I it was configured to force guest. So force guest is the default on non-domain joined systems. And it corresponds to a setting here which says network sharing access and security model for local accounts, because I can't talk today. And if that's set to guest only, which is the default on like home editions or non-domain joined systems, which corresponds to symbol file sharing, then you will be blocked even if you do have an admin account. Even if it is the 500 or UIC is turned off, you will still be blocked from PS execing. And according to Microsoft documentation, forced guest prevents local administrators, or how they phrase it is forced guest forces all local accounts to authenticate as the guest account when enabled, and it is not enabled by default on domain joined systems. So you know what happens when you turn it on a domain joined system? That is what I thought, but that is not the case, because as the documentation says, forced guest only applies to the local accounts. However, the documentation is wrong. Forced guest has no effect whatsoever, and even though it says it blocks it, it doesn't actually block it. So that was a surprise to me, again, in the past few months, actually testing some of this stuff. So basically, authentication is complicated. Again, we have the special rights assignment. So we didn't even go into, you could add somebody's account to the SE-deny network logon access right, even if they had SE network logon access right, or you could revoke SE network logon access right and still block it. In versions of Windows equivalent to 7 or later with sufficient service pack, you can do special SID restrictions, so you can apply those SE network logon rights or deny network logon rights to only local accounts. There's a special SID for that, or local accounts and members of the administrators group. And of course, there's firewall policies which you can run into. And you're like, all right, so I've done all that. I've turned UAC up all the way. I have blocked the local accounts from SE network logon right via special SID restrictions. I'm good, right? Except you're not. Because all that works for remote service management, like PSExec, and all works for remote file share access, which you can use to achieve code execution via something called the WBEM MOF method. And you can use remote registry access and task scheduler and WMI and Windows remote management, all of which are separate mechanisms of taking over a standard Windows system, and all of which ride off of network logon. And it's important to consider all of these, because what I frequently see is in companies, they'll say, well, we're blocking Windows remote management, so we're going to stop all that, hackers from taking advantage of that. And in reality, hackers have at least 5 other choices which they can use to achieve the same result, which is popping your box. And so a lot of times those restrictions aren't particularly valid, or they'll block lots of them except for one. And so you have all that, and that all works for network logon, but there's, guess what, a completely different set of rules for remote desktop. So all your UIC settings, which blocked your local admin accounts, don't affect it. However, that's okay though, because you need an actual password to do remote desktop logon. Except you don't need an actual password to do remote desktop logon in Windows 8.1 and later, because there's this great security feature called restricted admin mode remote desktop. And restricted admin mode is great because basically you can pass the hash to remote desktop without knowing what the password is, and still get remote desktop. Once you've done that, your account on that remote side won't have your password in memory like it otherwise would have. So it's a way to help avoid spreading your credentials. If you're doing domain management, you should use restricted admin, because then you don't give your credentials off to that remote system. But it does have the side effect of undermining all of the UIC restrictions which prevented lateral movement to using the local workstation accounts. And you can absolutely use restricted admin mode with those local accounts. And so, of course, it's got its own set of SE remote interactive logon rights and SE deny remote interactive logon rights to enable or disable that. And so you're like, all right, I have nothing open. I've got a domain box. It's got remote desktop disabled. Yes? Yes, kind of. If you start off with a remote desktop connection and you don't specifically ask for restricted admin, it will give you a non-restricted admin. So you have to throw that on as a separate switch on the MSTSC command prompt. And I'll talk a little bit about mitigations at the end on how you can force that in a bit. So if nothing's open, so we've got remote desktop disabled, we turn the firewall to block all of those network logons, any inbound connection whatsoever. So the question is, this box is just sitting there in the middle of the room, nobody's touching it, so you can't target a user, and without using an exploit, can you pop this box? Does anybody have any ideas? No, because your firewall is blocking that. So you've put everyone in the deny network logon, you put your firewall up, they can't connect to you. Can they control your system? Yep. That's right. Of course you can pop it. You compromise the domain, you apply a group policy to it to set a particular registry key like a app init DLLs, and then it goes and pulls a DLL from your server, and you've got code execution in about 20 minutes to an hour. Again, without anybody ever touching it. So again, you've got other methods like that. So why do we care about all the nitty-gritty details of Windows authentication? Well, if you continue to show false positives, you get treated like the network intrusion detection systems or like the vulnerability scanners. This is always a pet peeve of mine. You look at take a vulnerability scan of a PHP installation, for example. They'll say, okay, this is PHP 5.2. Let me look up, oh, you've got 5,000 CVEs on PHP 5.2, and here they all are, and it looks awful. And then if you actually look at what those CVEs are, 99% of them, assuming you haven't done anything weird like run PHP as a CGI or something, if you've just done the default install, 99% of them, actually 100% of them, are irrelevant to you. They only apply if you are, let's say, running a shared hosting provider and you run untrusted PHP code from somebody else, and then they could use that PHP code to get code execution, which is a stupid security model anyway. If you're going to let somebody run PHP code, just treat it as equivalent to code execution, because it's basically equivalent to code execution. And yet, because somebody somewhere tries to make that a security barrier, you have 10,000 CVEs, and most of them are just meaningless. And so we want to avoid doing that. If we want to tell you, you've got an issue with credential theft here, we want that to be accurate. All right, so we put it all together. I put up 3 systems on a test domain. One of them is a domain controller. The other ones are domain join workstation. Pulled all our data back. And so the question is, what happens if Bill Loney from HR gets his password phished or compromised or runs an executable or something like that? So let's see what happens. So here's Bill Loney, and what we found was that Bill Loney has a reused password, and so you can draw a link from his circle to the credential circle there, corresponding to that reused credential. And it turns out a lot of other people share his password, and we'll just say this is very similar to basically every real network we've scanned, which shouldn't be too much of a surprise. So what we see is oftentimes a lot of reused credentials, not just within a domain. So here you find a few other accounts, no privileged domain users or anything. But you also find the local admin accounts of at least 2 systems. And so these are the 2 workstations. And so once you have those accounts have rights over their respective workstation. So you then draw the links there. And then, well, if you look at those workstations, those then have access to a whole lot more accounts. So they've, of course, got access to all the hashes of their local accounts. But as we can see, at least one of them also has a token of Jurassic, which is the domain user sterling.archer. And sterling.archer has privileges to do pretty much anything. He's a domain administrator, so he then has rights over the domain controller, which is class, which then, at that point, of course, has all the rest of the hashes for all the domain users on it, leading to complete domain compromise. And so what you found here is that when you've put together not just what does this guy have rights to, which is what most IT analysts are looking at. They're saying, what's his group? Does he have the appropriate rights? Yeah, looks good. But also, where can he get from there, not just directly, but indirectly by following all those links? And what we found is that about half the accounts and all of the systems in the domain are equivalent to full domain control. And that's generally regarded as a bad thing. And that was just the shortest path that we graphed from that account to full domain control. There's also lots of other paths which you could also take, which will get you the same result, leaving quite a hairy mess to clean up. So the question is, what you then want to find is where can you make the biggest difference? Because again, you don't want to necessarily start off with, you do want to fix all of these, but you want to be able to say, what's the biggest deal? So what we've done here is we've said, what happens if we disable the sterling.archer account? And then, in that case, if this guy who is our trouble admin who went and logged into workstations he shouldn't have logged into, if he had not done that, this is what the new graph looks like. And so you have, we'll find it later. So you have right here is your domain controller and your domain admins. These are always going to be your red ones. These are always going to have full control. That's expected. But now, this big clump over here is now yellow, and yellow is better than red, right? And so yellow is all of your workstations and local accounts there. And they still have their own issues. We already know they've got to reuse local admin password, which is a bad thing. But at least they're not equivalent to full domain control now. So we've kind of identified what the problem is and at least made it a little bit better. And we can move forward from that point on, figure out who's causing our issues. So again, if Bill got phished, it's still bad, but it's not immediately horrendously catastrophic. You have more of a chance to catch things. All right, so now that we know kind of what the issue is and kind of how to clean up for it, how do we prevent these types of issues from happening again? And so one of the things that you can do is start applying some of those deny network access logon rights, apply it to all the groups that you can. Certainly all the local groups, they shouldn't be using remote network access. We also want to enforce on your domain users restricted admin if we can do that. So in any instance in which you're doing this, you're probably going to have some system in which they're going to want to double hop from, and you can teach them how to manually do that, or you can add that as an exception. And this is what I really don't like about Windows. There's basically two main modes you can do this. You can do it as default, give your credentials away. That's a bad thing. That's how things are normally done now. Or you can have it as forced, nobody can give their credentials away unless there's a specific exception. I really wish in a future version of Windows, I don't know if there are any Microsoft people here, I really wish they would make it so that you could set a default, don't give your credentials away, but you can add a special flag if you really need to. And then you wouldn't have as much of an admin revolt. But as it is, I definitely recommend this if you can do it. You go into group policy, you flip the switches to disable delegating saved credentials to remote servers, and then a few of the other delegation settings, and you can avoid giving your creds away, and basically remote desktop will by default always happen in restricted admin mode. All right, what else can you do? If somebody does have to go put in their credentials into a box, the best thing you want to do is you want to make sure that those credentials get invalidated as quickly as possible. And so the best way to do that, and it also helps solve like 15 other issues with passwords being stolen and reused, and because let me guarantee you, if you have passwords on your network, you're going to see just as many reused as they do everywhere else, and you're going to see just as many awful passwords as they do everywhere else, and most of them are going to be cracked just like everywhere else. And so I'd recommend using smart cards with an offline CA. That's another thing that we do detect, by the way, is popping. A lot of people do an online CA. So if you were able to compromise one CA, which is maybe a subordinate of an offline root, but it doesn't matter if that CA is in the trusted chain as your anti-auth store on your DCs, then you can issue yourself certificates valid for smart card login, and then use that to gain control of the domain. And so you definitely want to at least highly restrict those. Maybe you can't do a full offline CA, but maybe you can rotate and revoke at a regular schedule the certs that are on the network permanently. There's a question in the back?
That's also mitigated if you use an HCA, yes?
Oh, I'm sorry, can you say that again?
If you're using hardware crypto,
So that certainly helps a lot if you use a hardware security module. HSM, so that will prevent you from stealing the actual CA's root or the actual CA's private key, but you can still get control of that CA and issue yourself a cert which is valid for as long as the CA is valid. So, you know, there's still that potential there. Let's see here. I also highly recommend automatically and daily randomizing both your smart card user hashes, and then I would recommend every week randomizing your TGT hashes. We can have long philosophical discussions on how frequently you should do that. If you do it every week, you have very little chance of, you have no chance of invalidating an existing Kerberos ticket. And if you use the Microsoft script to do so, you've got very, very, very small chance of issuing tickets which are invalidated on certain DCs. But that is the account password which is used for Kerberos authentication. If you steal that hash, then you can forge Kerberos tickets forever until that hash is changed, and it's only changed if you do it. So you need to do that. What else? So authentication policies and silos. So this is something which is really cool, something which has been added to 2012 R2 and later. For any versions of Windows domain prior to 2012 R2, basically you could restrict logon workstations, you could restrict the target logon of a particular account, but you could not restrict the source of that account. Authentication policies and silos can do that for you. They can make it so even if I've stolen your credentials, if I'm not coming from a system which is necessary for me to come from, then I still get denied. And that's a really cool thing that they've added. However, I will warn you that one is complicated to configure, but sometimes what you're going to do is you're going to have someone's going to say, well, the service has to run as admin, and it has to have a password saved, which is a really terrible thing, and it has to have network logon rights. And if that's the case, I would advise finding a different vendor, but sometimes there's those situations in which you've got this terribly insecure thing, and at least for now you can't change that. You can use something like authentication policies and silos to help mitigate that risk so that doesn't become as much of an issue. What else? Highly recommend blocking NTLM, at least inbound for all Windows domain systems. Makes passing the hash a whole lot harder. You can no longer directly pass the hash. You can still overpass the hash for a Kerberos ticket if password logon is allowed. So again, if you do this and you enforce smart card login, then you've got no saved creds on the network or in memory at any time for that account. So this is really nice. The biggest thing that I've found that this doesn't work on is if you disable NTLM authentication entirely, or you disable it outbound, and then you have like some weird printer or some weird proxy which only works with NTLM, and then those don't work. But you can disable it inbound on your Windows systems, and that's a lot easier. You can add exceptions if you want, and that will prevent a lot of these credential reuse attacks. All right, so that was kind of on our defensive side. Offensively, what can we do with this? And I understand I'm the only thing standing between you and freedom, so I'll try to hurry up because I know I'm always running late already. So offensively, what you want to do is, everybody knows about token hunting, capturing, reusing, dumping hashes. If you map out the network like we do defensively, you can identify a lot of locations to persist, which are great hiding places and will have recurring access to those credentials. So that's a really useful way to do this. A lot of times, systems like domain controllers and other servers, they get the tighter, app blocker security policies, they get the tighter inspection, and you can kind of avoid leaving your persistence there. Another thing that we did was, let's say you want to figure out how password reuse happens. One option is to get a username and a hash or a password and try that against everything. This is kind of a bad idea because you quickly lock out accounts. You might blow up a SIEM if they have one of those. So how else do you identify if another account has the same pass or hash word? Same hash or password. Another thing that you can do is to set up an NTLM capture server, distribute UNC paths around, watch the NTLM challenge and response come back, and then try to brute force those offline. So to my knowledge, prior to us releasing this script, nobody had found a way of doing this with the hashes alone. There are various systems out there like OCL Hashcat, which will allow you to brute force the challenge response just with the challenge response, and they're going for passwords. But what we did was we wrote a script that will allow you to do it with a hash. So if you've captured the hash and it was reused somewhere else and you can't crack it, no matter how good the password is, you can still identify if it's been reused on another account. And I will do that super fast here. All right, so we have, hello. So we've got a system here. Where's my mouse? MSF console. Because somebody removed MSF CLI. I don't know why they do that. And once we start with that, so this is going to be our victim. So we've done a hash dump of one system, and we've got, I think they're here. No, they are somewhere else. We'll find them later. Oh yeah, they're on the desktop. So here's our hash set, and we've dumped it from somewhere, and we want to find out if anybody else reuses any of these hashes without being able to crack them. And so we're going to use auxiliary server capture SMB, and run that. And we are at 56.101, and so we spread a link or something, or give them a link to click on, and they go to 101. And what do we get? A whole bunch of challenge and responses using our spoof challenge. And so we can see it's user bob.barker coming from MSIE Vista, and he's got these various challenges. So what we then do is we do Ruby NTLM capture hash check, and this one, there we go. We give it the account name, which is bob.barker. We give it the client challenge, which we cut from here, the one that says client challenge. And we put that there. We do domain, which is whatever they told us the domain was, which in this case is MSIE Vista. And then we do the NT hash response, which is in the section called NT hash. And we do the server challenge, which in this case is the default because we ran our own capture server, which spoofs the original server challenge, so we won't need to put that in there. And we will test this file, which is root desktop hashes. And we run that, and ta-da, we've found a matching hash. So again, without cracking this hash, we've identified that this new account that we didn't have the hash for has a reused hash of account we did have the hash for, and this new account might be more privileged, and we can then use its credentials, pass the hash, and take over from there. So that's our demo. And Windows is most certainly genuine. All right, and that's in the Root 9 BTech NTLM repository on GitHub if you want that. I think it's actually now in Root 9B. somebody else had taken the Route 9B repository, which we then good? All right, so pay attention to creds, do cred research, check for your creds, check your privilege, identify new and reused credentials, and use them to persist or do offensive or defensive work whenever you can. Are there any questions? I don't think I ran too far over.
Can you talk any about derived credentials?
Sorry, can you say that again?
Can you talk any about derived credentials?
Derived credentials?
Yeah.
So like what specifically? There's things like Kerberos tickets, which you get from, you pass your original password or smart card certificate or whatever else, and then you get that Kerberos ticket, and that's good for a certain period of time. And those can be stolen, but aren't necessarily valid for as long as some of the other ones.